Kana, very good afternoon to all. So today's session, construction materials. Okay, so this topic is handled by Anju madam. So presently he is a research scholar in IIT Palakad. Okay, so during this session, if you have any queries, any related materials or voice not clear, video is not clear, means kindly post your confirmation in the chat boxes. Okay, so all of you can stay online and inform to your friends to join this class immediately. Okay, ma'am.
Yes, sir.
Okay, you can start the session, ma'am. You can start the session and to complete 3:30, ma'am. And after 3:30, you discuss with feedback and any other related topics, ma'am. Yes,
Okay, sir.
related to gate, ma'am. Yes, ma'am. Yes. Thank you,
Okay,
ma'am.
sir.
Yes,
Okay, thank you so much, sir.
yes, ma'am.
So, good afternoon to all. As I said, myself Anju Ajay Kumar, and currently I am doing my research from IIT Palakad, and I am doing research in construction engineering and management itself. So, thank you for giving me an opportunity to take a class in this gate coaching section. So, without delay, I am moving on to our presentation. Just give me a minute. So can you please confirm whether my screen is visible or not?
Everything is okay, ma'am.
Fine.
Yes, ma'am.
Okay. I hope that the section is recorded and is started, right, sir? Hello?
Ma'am, yes, ma'am. It's always in record, ma'am. Yes.
Okay, thank you. Thank you so
Yeah,
much, sir.
yes, ma'am. Yes, ma'am.
So students, in our concession materials and management, and when you are looking to the previous year's question papers, this subject is getting importance for the last few years only. When from exactly saying from 2020 onwards, nearly 4 or 5 marks is covered to this particular subject. So in our topic, like in our syllabus, we have to cover the construction materials, like that steels, timber, questions from timber sections, steel sections, concrete sections, and bitumen sections are most common. And in regarding the planning, means management section, you can expect questions from the network diagram, or like a critical path method, or the crashing problem, or something like that. You can expect questions from material side as well as from the network diagram side. So I am including here some of the important materials from which gate oriented questions are coming. So first one is structural steel. So what I am studying is, what I am trying to tell you is not in a brief, not in a regular class, just pointing into the gate point of view. You have to know some of the basic objectives or some of the basic questions about structural steel. So the basic requirement for any material is that a standard code. For structural steel, it is we are using Indian Standard 800 2007 revised version is the code which we are referring. I think you might have used in your structural steel design this code. So this is the code which we are regularly using. So what is structural steel? We are going for the steel structures to improve our construction methods, or to reduce our time consuming, or reduce the wastage and all. Moving from concrete to steel, we have so many benefits. So we are using this particular code for the design of structural members. And the structural steel is available in different forms, like rolled steel, beam, channels and angle sections, metal strips, sheets, bars. It can be in rounded shape or square shape, flanges and plates, T-bars and bulb angles. All these sections you can, when you go to the structural steel structure, like in your laboratories and all, you can have this truss work and all. You can find some of the structural members there. According to the shape of the structural steel members, several other codes are also available. But most of the time, the question is from that which some of the one once they have asked regarding the Indian Standard Code. So from this slide, you can expect a question regarding from the code IS 800 2007. Next question is from your composition of structural steel. So you know that steel is not a single metal. It is an alloy of iron, carbon, chromium, nickel, and many other elements. So the components or the chemical elements and its propositions or its ranges in that particular member and its function. That area is another date-oriented question area. So first one is carbon. It is the most important chemical element in the steel. If the carbon content in an alloy is increased to a certain level, then the strength can be increased, but the ductility is automatically get reduced if we are increasing carbon content to a certain amount. So the permissible amount of carbon in the steel structure or steel member is 0.05 to 0.3%. Another important member is manganese. Manganese has a percentage range from 0.50 to 1.70%. It has effects similar to those of carbon, and the steel producers nowadays uses these two elements, means carbon and manganese together in combination to achieve certain desired properties to the structural member, like in steel. Another important element in steel is aluminum. So when we are speaking about aluminum, the function of aluminum in steel is a deoxidizer, and it helps to form more fine grained crystalline microstructures. So aluminum is the function in steel is that it is an deoxidizer. It protects it from corrosion and all. And next one is chromium. It is primarily used to increase the corrosion resistance of the material, and for that reason it often combines with nickel and copper also. So it ranges from in stainless steel. You may have noted that stainless steel without corrosion, we have a combination of copper and chromium in 18% and 8% respectively. Next primary anti-corrosion component in steel is copper, which should not be less than 0.2%. Then molybdenum, it increases the strength at higher temperature and increases the corrosion resistance. One thing you have to note that the steel will behave differently at different temperatures. So at higher temperatures, this component will enable the steel to withstand the load acting on it, and it also improve the corrosion resistance. Next one is nickel. It is, as I have already stated, it is in combination with chromium they are using. It's also a corrosion resistant agent, and at lower temperature, it improves the fracture toughness. And last component is that silicon is a principal deoxidizer. So you can expect a question like the principal deoxidizer. You have the options like aluminum as well as silica. So you have to go with silicon here. Its percentage should be less than 0.4% for a structural steel member. Next one is like the general property of a material. For any material, we have different properties. For structural steel, we are defining its strength, toughness, ductility, and durability. So what is strength? We are providing these steels are reinforcement. Why we are providing? We are providing for this tensile strength. So its strength means strength in structural steel means is tensile strength itself. It increased with increased hardness of the material. It increased with increased hardness of the material. And next one is toughness. If the steel is insufficiently tough enough to have the load, then the cracks are started to develop. These cracks will further propagated on further loading. So toughness is another important property of the steel. Next one is ductility. Ductility can be defined as the measure of the degree to which a material can be strained or elongated between the yield point to the fracture point under the effect of tensile loading. So from the yield point to the fracture point, how much elongation it can take under the action of load. That is the definition of ductility. And last one is the durability. As you know the term meaning durability, it is the resistance to wear and tear of due to weather or continuous corrosion actions or anything like that. This material should be durable. That is the basic property. And that much is enough for steel. You can expect 2 questions or 3 questions from this steel component. Next one is, one important factor is concrete. So we know for a civil engineer, it is a basic material and it is a man-made material as well as a composite material. So you know the components of concrete, like we have cement as binder, coarse aggregate as filler, fine aggregate as filler, and coarse aggregates as strength, and admixtures, additives, and all. Some X atoms are there in concrete. So it is a composite material. It is not a single material. So it is a composite material and it's a man-made material. And in its green or wet concrete means its fresh state. Before setting time, before attaining its setting time, the concrete is said to be in a green concrete or green state or wet state. And in its dry state, definitely it is called as hardened concrete. So the constituents of concrete are coarse aggregate. So the coarse aggregate means what? That aggregates with size greater than 4.25 mm. That's a coarse aggregate. So the action of coarse aggregate in a concrete is they will act as the fillers. So next is fine aggregates. Their size less than 4.25 mm. That is fine aggregates. That will fill up the voids. And next one is combination of water and cement. That is termed as binder. Next two important things that you have to know is admixture and additives. So what is the difference between admixture and additives? Additives are something external component we are adding to the concrete during its manufacturing stage itself. Example, gypsum. Gypsum is an additive we are adding to the cement during its manufacturing process in order to control the setting time of cement. We are controlling the property of a material by adding during its manufacture stage. That X material we are adding are called as additives. What is the difference between then what is admixtures? Admixtures is nothing but which are external agents or external materials which are adding to improve the properties of the material. But the difference is that admixtures are added during the making stage of concrete, like our cornplast. Cornplast is a superplasticer. It's an example for superplasticer cornplast. So this cornplast is added to improve the workability of the concrete. Okay. Next is water cement ratio. Water cement ratio means that binder ratio or water cement ratio. Usually according to IS 10262, we are providing a optimum water content of permissible water content of 0.4 to 0.6 to based upon our strength, grade, porosity, etc. So the mixed design, we have standard grades of concrete. Like in you can see in the table, like M5 to M25, we have standard mixed designs. Like we know the standard proportions of cement is to fine aggregate is to coarse aggregate. But above M25, we have M30, M35 up to M60, whatever it is. So for that purpose, we have no particular proportion of this binder is to fine aggregate is coarse aggregate. So in that case, we are going for mixed design. According to the material specification we have, like specific gravity of the fine aggregate, binder, whatever it is. For that, we are using a particular code. What is that code? That is IS 10262-2009. So this is a code which we are using for our mixed design. Then moving to the table, we have different grades of concrete. M5 concrete, M7, M7.5, M10, M15, M25, M20 and M25. What is this? M means? M means mix, and these numbers represents the compressive strength which we are expecting from this proportion of materials. When we are mixing this proportion of material, we are expecting this quantity of compressive strength at the age of 28 days curing. Okay, we are casting a cube of M10 today, and with this proportion 1:3:6 M10 we are casting today, and we are expecting to get a compressive strength of not less than 10 Newton per mm square or 10 megapascal at the age of 28 days curing. After 28 days curing, we need to require 10 Newton per mm square. Like that it varies. Okay. So you have to remember these ratios as well. Next is short-term and long-term properties of concrete. That is nothing but the stress and strain, as well as the Poisson's ratio, as well as creep and shrinkage. These are the four important long-term and short-term properties of the concrete. So what is stress and what is strain, first of all? Can anyone reply me? What is stress or what is strain?
Stress is force by area.
Stress
Strain
is
force by area.
strain is force by area. By equation wise, you are right. Okay, stress is also force. Okay, let me explain you. If I pull you a bit, you have a resistance from your internal body to not to fall down, right? Can you hear me? Hello?
Yes, ma'am, you are audible.
Yes, ma'am, you are audible.
Yes, if say any person, see with roll number 5 maybe here, I am trying to push him down. He tried to resist to not to fall down, right? So that internal resistance offered by him is known as, that internal force offered by him to resist the push that I have given is called stress. So in a concrete, it is nothing but the internal resistance against the load applied, or internal force developed within the body against the force applied. That is stress. Strain is nothing but the deformation. Definitely concrete is taking so many loads in their lifetime. So it has to go through this stress strain. So we have a stress strain relationship. I hope you have studied the Hooke's law in your structural classes. Right?
Yes, ma'am.
What is Hooke's law?
Within elastic limits, stress is directly proportional to strain.
Good. Most of the time, just explain like stress is directly proportional to strain. That is not Hooke's law. Within that elastic limit, that term you have to mention. Okay, within the elastic limit, the stress is directly proportional to strain. That is applicable for all the material. But after the elastic limit, what will happen? It can go up to, it can take more load, and after that it will fail. Okay, so I'm not moving to the structural part. I'm back to our topic, like stress strain curve of concrete. As the graph is shown, you have the 40%. It will the first portion of the curve represents the 40% of, which will represent the ultimate strength that a concrete can take up. And this 40% relationship is linear, means linear relation between stress and strain. That means they are equally proportional as per the Hooke's law. So this 40% is fine. After this 40%, the lower the strength of the concrete, the greater will be the failure strain. That is the relation that you have to identify from this graph. The lower the strength of the concrete, the greater will be the failure strain. Okay, and we have the elastic constant also. So what is the equation for elastic constant for concrete? This can be a question. Elastic constant of concrete is 5000 FCK. FCK is nothing but the characteristic compressive strength of the concrete. So the range, we have a range for the elastic constant for concrete. Nothing but 14 to the power of 10 raised to 3 to 40 to the power of 10 raised to 3. 14 into 10 raised to 3 to 402 into 10 raised to 3 Newton per mm square is the range of elastic limit in concrete. Next, short-term or long-term property is Poisson's ratio. Poisson's ratio, you have a code word I will give you, LALI. Poisson's ratio is nothing but LALI. Lateral strain to linear strain. It is the ratio of lateral strain to linear strains. So Poisson's ratio, LALI, that's it. Lateral strain to linear strain. You have equation like lateral stress to linear strain as well as lateral strain to linear strain or linear strain to lateral strain. This kind of confusion will be there. First of all, you have to identify that. First of all, you have to sort out that it is a strain. It is a deformation ratio. Poisson's ratio is a ratio of deformation. So it will definitely come under strain. So LALI is the code for Poisson's ratio is lateral strain divided by linear strain. and its value ranges from 0.15 to 0.20. And what is creep? During course of time, during continued deformation with time under applied load. We are continuously applying load to a concrete, and during course of time, it shows a deformation. That deformation is defined as creep. This creep is not a deformation which is suddenly observed. During a course, maybe you can observe creep in a beam at the age of 15 years after construction. So during the life cycle of the building, this deformation occurs due to the continuous application of the load, especially cyclic load. That can be defined as creep. So the deformation with time is defined as creep. Next is shrinkage. The contraction of the concrete in the absence of load is known as shrinkage. That is like we have a sponge in your hands, and we have the smiley ball. Say example, take the smiley ball. You have the smiley ball in your hand, and you are pressing it. It get deformed, and when you are releasing your fingers, it just came back to the original shape, right? So the same property happens in concrete also. It will contract when the load is applied, and it will retain back after the load is applied. After the load is being removed. That is shrinkage. So concrete can also undergo shrinkage. It can be found out using the formula S is equal to 0.00125 into 0.90 H, where H is the relative humidity. Once in a gate question, the equation is not the equation. The calculation is asked for 1 mark question, I think so. So that's it from concrete side. Next important material which we are dealing in our construction site is nothing but the brick. So you know what is brick and all. I don't moving into the basics of brick. Just from gate point of view, how will you measure the length of a brick? Length of the brick is nothing but 2 into width of the brick plus thickness of the mortar. You may give calculation, or you may give the equation. What is mean by length of the brick? We all know brick, and we all know the standard size of the brick. That all things we know. So what is the length of the brick? That is the width, double the width plus thickness. Length is nothing but double the width plus thickness of the mortar. What about the height of the brick? It is equal to width of the brick itself. Next, as you all know, the standard brick or the modular brick have the shape of a rectangle cube. Like it's have 19 by 9 by 9 centimeter or 19 by 9 by 4 centimeter, which will be replaced with 20 by 10 by 10 after applying the mortar. That's, you know, the basic standard size of the brick. So the question can be from the length of the brick or height of the brick. You can expect from brick side. And we have 3 different classes of bricks. First class bricks, second class bricks, and third class bricks. Okay, I am moving from left to right. What is third class bricks? Even in our class, we have 3 classes of students. Like that, in our market, we have 3 classes of bricks. These third class bricks, these are light color bricks with soft texture. They will produce a dull sound when stuck against each other. And this water absorption is 25% by dry weight, and it is used for temporary structures. From these 4 or 5 points, you can classify this into third class bricks. So this is the lowest class of the brick which can be used for a construction work, especially for the temporary structures. Next, a bit better version of third class brick can be termed as second class brick. A little better version of third class brick, that is second class brick. It have water absorption 16 to 20. You have a range, and crushing strength should not be less than 7. And it is recommended for unimportant hidden masonry works like that. And what is first class brick? The good quality bricks used for load bearing walls or whatever it is classified under first class bricks. So you have to note the water absorption of these 3 classes of bricks for your question, and the crushing strength of the how you define this belongs to first class. Sorry, how it belongs to first class or second class according to the crushing strength and all. And for this work, what class of brick you are using? That is the question that you can expect from here. So first class bricks we are using for good works or masonry structures or flooring, whatever it is. We are going with first class brick with where we do not need a compromise for the strength. Second class brick can be used for unimportant works of concessions. But third class bricks we are using only for temporary works. This is the classification of brick. Hope I am clear with this. So you have to note the water absorption as well as crushing strength and the use of these three classes in each situation. Next, the general characteristics of a good brick. What all are the general characteristics of a good brick? It should be uniform size, uniform texture. These are questions you can't expect in a gate. What you can expect is water absorption, crushing strength. The 7th and 8th point you can expect a question. That water absorption should not exceed 20% in its dry weight when kept immersed in water for 24 hours. Okay, if a brick have water absorption of 25 or 40, it is not the characteristic of a good brick. Similarly, if the crushing strength not less than 10 Newton per mm square, it's not belongs to a good brick. So you can expect a question from 7th point as well as 8th point only. Remaining all things are just theory factors. You no need to study for your gate syllabus. And next important thing is the ingredient of the brick and their range and proportions and all. So when we are just seeing the red color or the compound color on the surface. But inside that we have many chemicals components in it, in our brick. So what all are they? That is, first one is silica. The major component, major ingredient in our brick is silica. That is 50 to 60%. And alumina 20 to 30%. Lime 10%. Magnesia less than 1% or less than 20%. Sometimes like that 7%, then ferric oxide 7. That this ferric oxide is offering actually red color to the brick. And this alkali is carbon dioxide and water. This composition you have to by heart in any way. Next important question that you can expect is the testers on the brick. They are not asking you the procedure and all in gate. They're asking something different. Maybe the range value or the code from which you are getting this test. How you conducting the testers. For the testers on the brick, we have only two codes. IS 1077 and IS 3495. IS 3495 has 3 parts and each part represents each methodology for testing the brick. First one, IS 1077. This is the Indian standard code which is used for dimension testers in brick. And the compressive strength test is from part 1 of 3495 and water absorption test in part 2 of same code 3495 and efflorescence test. The efflorescence test, I hope so. The white color presence of that mixture, that is in part 3, 3495. Next component which we are commonly used in our concession site is mortars. Okay, so it is a combination of just our binder as well as our fine aggregate only. The coarse aggregate component is not there. You have the classification of mortar, like heavy mortar or lightweight mortar. Based upon what we are classifying. We are classifying based upon the bulk density we are classifying. It is if the heavy weight, if it belongs to heavy weight, bulk density will be greater than 1500 kilogram per meter cube. And it is in that we are using the aggregate. What aggregate you are using for your heavy weight mortars? Heavy quartz or sand is used for your heavy weight mortars. And for lightweight mortars, we are using your light porous and sand and slag-like materials. Based upon the binder material we are using in our mortar, we have different type of binders. Different type of mortars. Like cement mortar, if the cement is used. Lime mortar, if lime is used. If gypsum, I have already mentioned gypsum as an additive. If gypsum is used, it is gypsum mortar. If composite materials are used, that means like surki is an example of a composite material. Surki means surki plus lime plus water. That is a composite. We have X1, X2, X3, X4, n number of materials. That surki is an example of composite mortars. Next, based upon the application, we have bricklaying mortars, finishing mortars, special mortars like that. Special mortars is nothing but for acoustics or X-ray rooms. We are providing something different mortar for the shielding power of that radiation rays and all. That are some kind of special mortars. Then characteristics of good mortar. You need to explain anything in that because I think it's just simple by words itself. Next important part of the material from which you had expect a more number of question is timber part. So the classification of timber and the grade of timber classification. These two are mentioned in Indian Standard Codes IS 399 and IS 6534 respectively. So we have to know the structure of the timber. Then only we can go into the decay or decay and defects and what else? Defect, decay, diseases in timber and all. So you have to know what are the parts or what is the structure of a timber. We are using timber in our construction for many of the like windows, doors, cupboards. We have many applications of timber. So we have to identify or we have to know the structure as well as its during lifetime what are the factors is affected. So first in the as shown in the figure, we have a bark portion. If you have a wood in your tree in your hand, you can see that a bark is there. Means outermost layer. Bark can be divided into two: outer bark and as well as inner bark. It is the outermost layer of the timber. This bark protects the wood against mechanical damages. The first protection giving layer is the bark. It gives resistance or against mechanical damages. Its inner layer is called blast, conveys the nutrients from the crown downwards and shorts them. The function next is the after the inner bark also we have the layer called cambium layer. Okay, the cambium layer also has a function. The function of cambium is to grow wood cells on the inside and small blast cells on the outside. Next is the sap wood. After the cambium, moving inward, next is the sap wood portion. It assists in life process of the tree by storing up starch and conducting sap. The cells in the sapwood are active. The cells in the sapwood are active. Next portion is the hardwood. Hardwood gives a strong and firm support to the trees. Within the growth of the tree, the cell in the inner older portion of the trunk gradually becomes inactive and lifeless, but do not decay. This hardwood, I'm speaking about this hardwood portion. Actually, they are active in its initial state, then later on it goes to inactive state, but it won't get decayed. This part is what we are using for our construction works. And the center portion is called the pith. So these are the structures of the timber. Next, we have three category of damages in timber. First one is defect, second one is disease, and third one is decay. First I am speaking about the most important defects in timber. Defects in timber. First one is checks. Checks is a longitudinal crack which is usually normal to the annual rings. These annual rings are nothing but in our figure we can see round rings inside this from this sapwood area to the pitch. These are known as annual rings. So these annual rings, by measuring the annual rings, we can able to identify the age of the timber. So the longitudinal crack occurring normal to the annual rings are known as check defect. You can see it's in the figure itself. You might have observed this in your desk or bench in your classrooms. Next one is shake. The longitudinal separation in the wood between the annual rings. Between the annual rings, you have the longitudinal separations. That can also be observed in your desk and benches. This lengthwise separation reduces the allowable shear strength without much effect on the compressive and tensile value. That is the shake. So this shake as well as cups based on the both are longitudinal cracks to the annual rings. Okay. Next is the hard shake. It occurred due to the shrinkage of hardwood. We know the hardwood portion, the most portion which we are using for a construction part, where the tree is over matured. When the tree is getting over matured, the shrinkage of this hardwood portion occurs, and this crack starts from the pitch and runs out. That is called hardwood. Next is cup shake. An appearance of a curved split which partially or wholly separate annual rings from one another. So these annual rings are got a deformed from its original state. That is another defect in timber. And the last defect is star shake, or radial splits or cracks with arc circumferences and diminishing towards the center of the tree. There are star shakes. Next defect in timber is wrinkles and upsets. You can see in the figure itself, wrinkles and upsets. Wrinkles is characterized by the swelling caused by the growth of layer of sap wood over wounds after the branch has been cut off in an irregular manner. Like in a wind, a branch is broken from a tree. That broken portion of the tree will start bulging little. You may observe in your plants around. That kind of defect is known as wrinkles. Upsets are caused by the crushing of fibers running transversely during the growth of the tree due to strong winds and unskilled feelings, constantly resulting in the discontinuity of the fibers. So this fiber getting discontinued, that is known as upsets. And moving to the diseases in timber. We have two diseases for the timber. First one is dry rot and second one is wet rot. I am damn sure that you have observed these two diseases in timber once in your life. Dry rot is nothing but decomposition caused by the action of fungus, white color sponges fungi is attacking our timber. It is mainly occurred when the timber is exposed to water content area. Exposed to water. The fungus reduces the fibers to fine powder and the timber loses its strength. This is dry rot, attack of fungus. What is wet rot? It is set up by the access of water through wounds in the bark. We have our outer layer bark. So water is penetrating into the center, into the timber through the bark and start decomposing the sap wood area and the fibers of the tree. That will result in the wet rot condition. It can also occur when the seasoning process of the timber, when exposed to moisture. So these two are the diseases of the timber. And last one about timber is the decay of timber. Decay of timber is nothing but we have 5 decays I am explaining. First one is attack of fungal or bacterial attack. The bacteria do not cause any serious damages to timber except for some discolorations. Fungi are system of plants organisms which live in the attacked timber causing rot or decay. That we have already discussed in our previous slide. First the bacteria will attack, and from the bacterial attack area the fungus will start growing and it will lead to the disease in timber. Next one is termites and white ant that we have observed in our home itself. Like insects shown in the figure. They are starting using this wood for their shelter or food storage, whatever it is. And due to this attack, this destructive insect agent for the wood in case of a timber, which we are speaking about, they start excavating our wood. So during excavation, what will happen? Our annual rings get broken and the fibers get broken, and finally our timber is reducing its strength. Next is another insect called beetles. It's a small insect which we are cause rapid decay within 1 or 2 days. With our wood is getting damaged. This is observed in our, we can see in our desk or benches. Under that we have white mustard-like pieces. That is because of the attack of these beetles. Next is pinhole borrowers, another common attack by the insects. They are less than 6 mm in size and attack both the sap wood and hardwood area. That is pinhole borrowers. You have seen this figure also in your classrooms, benches and all. At least in your school, not in our college. In our school, you can observe definitely. And last one is the death wish beetles, most dangerous thing that happened to the decay of timber, larger than previous one, and the tunnel made by these are so big, larger, and it can be observed like when we are watching from outside, we can see that we may feel that this tree is getting affected from fire, but it's not actually because of that. It is due to the attack of this insect. So this is the major decay of timber. That's it about timber. And last material which I am speaking about is nothing but bitumen. You all know bitumen, which we are using as a material for our road construction. Bitumen is a non-crystalline, solid or viscous material derived from petroleum by natural or refining process and subsequently soluble in carbon disulfide. So one thing you have to notice here, it is derived from petroleum and soluble in carbon disulfide. Non-crystalline, solid and viscous material derived from petroleum, and it is soluble in carbon disulfide. From it's clear that it is not soluble in water. Bitumen is only soluble in carbon disulfide solution. And in its dry state or in its solid state, bitumen is known as asphalt, and in its semi-fluid state, bitumen is called as mineral tar. And it's usually occurred in, you may have seen in black color. It can be also available in brown color also. And it do not have a particular melting point, a sharp melting point like other materials. And its softening temperature ranges from 30 to 100 degrees Celsius. There are different forms of bitumen, like bitumen emulsion, blown bitumen, plastic bitumen, cutback bitumen, straight run bitumen. Among this, we can expect a question from cutback bitumen. Cutback bitumen is obtained obtained by fluxing asphaltic bitumen in the presence of some suitable liquid distillates of coal tar or petroleum. So coal tar and petroleum is fluxing asphaltic bitumen. That is cutback bitumen. It is mainly used for road construction and in soil stabilization also, up to 2 to 4% only. Cutback bitumens are commercially manufactured in the 3 following groups: rapid curing cutback bitumen, medium curing cutback bitumen, and slow curing cutback bitumen. So you have to find the agents in the particular bitumen. In rapid curing cutback bitumen, it contains naphtha or gasoline. And medium curing cutback bitumen contains kerosene. Slow curing contains light oils or fluxing agents. And uses of bitumen is general. You don't need to expect any questions from that. So that's it from the construction material side. So if you have any doubt, just ask me from the material side. I am waiting for 2 minutes for any taking questions from the material side. Then we will move on to the construction management side. Students, so till now you are clear or not? Hello? Can you hear me?
Ma'am, how many marks can we expect from this, ma'am?
From material side, you can expect 4 to 5.
And all are 1 mark questions, ma'am.
Yeah, from material side, you have not that much equation type questions or not, just theory oriented questions.
Okay, ma'am. Thank you.
So the content from material side is clear for you, right?
Yes, ma'am.
Okay, fine. Then can we move to the concession management part? Shall we?
Yes, ma'am. Please.
Okay, thank you. So, my screen is visible, right?
Yes, ma'am. Visible.
Yeah. So, we have many activities in our concession. And the management of or the coordinating of these activities are termed as management, concession management. Like from morning to evening, morning 7 a.m. from your waking time till 11 p.m. in through your time back to bed. You are managing X number of activities. You are brushing, you are going to toilet, you are taking your food, you are getting ready for the college, and you are going to college, and the college you are meeting so many people and doing so many works, and you are spending your 6 to 7 hours in your college campus and returning back to your hostel and having tea, and you are spending some time with your friends or some activities, and you are going back to your bed. This is your one day, right? So we have a 24-hour schedule in our day. Within this 24 hours, you are doing more than 10 to 15 activities, right? So in a concession project, like a house concession, it may extend it to 1 year. So you can imagine how many activities are there. In a single day, you are doing 20 to 25 activities. Even though if it is repeating every day, you are doing 20 to 25 activities in your single day. In a productive day or non-productive day, whatever it is, you are managing 4 or 5 activities. Anyhow, if you have a test paper, you are skipping your film, or you are skipping your roundabout with your friends, or you are skipping your cricket, anything. You know how to manage things. It is human nature. So without studying or anything, we are managing many things in our life. So managing activities related to concession are known as concession management, nothing more in that. So project management is the process of leading the work of a team to achieve all project goals within the given constraint. So any project involves planning, scheduling, controlling a number of interrelated activities with the use of limited resources, namely men, machines, material, money, and time, can be considered as a concession management project. Like that, we have 1,000 rupees in our hand, and we have 700 rupees we have to pay in our hostel, and remaining 300 you have spent in different way. But we are still managing our economy. We are managing the amount 1,000 rupees in our purse. Without knowing the management side, we are automatically human nature, we are doing it. Okay, In our concession projects, we have three type of projects: federal concession projects, government projects, or private projects. Nothing important in that. Some questions that you can expect from this slide, like what is agreement, contract, or difference between contract and agreement, like that. Agreement is nothing but this is oral dealing, oral acceptance of an offer. If you are writing this assignment for you, I will give you a chocolate. It is an agreement you make with your juniors and seniors and all in your college, right? It's an oral thing, you are giving an oral offer, and the offer is accepting that oral offer. Okay, I will write the assignment only if you give me a dairy milk. This is an agreement. Then what is contract? When this agreement is coming into picture of a law, like legal conditions, that is a contract. Like if you are doing some X activity and I am paying you Y amount within this short period of time, otherwise you can go to the concerned authority for complaining me. Like that, the agreement can become a contract. All agreements are not contracts, but all contracts are agreements. This is a clause. Okay, when an agreement between two persons comes under the lawful consideration, it turns to a contract. Then obviously you know what is tender. What is tender? Tender is an offer in written format to execute something. Like we are asking for a company, L&T company, to do a construction work in our campus, and our estimation cost is 3 crores, and we are asking their cost. That can be a tender. And before tendering, we have the specifications, plans, estimate, and all is required. All is required. So what is specification? Specification means, you know, if you are buying a mobile, you have its specification, like internal memory, SIM card, 4G, 3G, 5G, like that. We have the specification even for your mobile that you have in your hand. So definitely for a concession project also, which deals with many crores of amount, you have specifications, general specifications and detailed specifications. Two type of specification is there. First is general specifications. Like in case of a concession building I'm speaking about, you have the foundation and plinth for all the buildings. That is general specifications. Or you have the DPC, dam proof course, for all the buildings. That is general specifications. So what is this detailed specification? Like the foundation and the plinth, in that you are used 40 mm aggregate only or 60 mm aggregate only. That detailed specification of a single general specification is known as detailed specification. In-depth specification of the general specification is known as detailed specification. Next one is estimate. Estimation is nothing but an anticipated cost of the project. This is a probable cost. If we are constructing a house, we are supposed to spend 30 lakhs or 40 lakhs. It's an estimate. So what you have to note from here is that it is for doing the estimate, what all things you require. Definitely the drawing is required, specification is required, rights is required, schedule of rights is required. Here comes the importance of specifications. If the room in which you people are sitting right now, consider that. It may be the flooring is tile. You have two options. You can go with tile or you can go with red oxide. You can go without tiling. Many options are available. So what is the cost difference? So specifications, importance of specification comes in estimation. Okay. Next is come to the technical part of management, that is project planning part. We have different techniques in management like bar chart, milestone network, all these things you know. So what is bar chart? I'm skipping directly to the technique. Bar chart. Like the name itself, it's mentioned. It is a chart representation of the activities. It is a chart representation of the activities. we have in a chart, what we have x coordinate as well as y coordinate. So in a bar chart, the x coordinate is used to refer the time and y coordinate represent the activities. And similarly for that of a milestone also, but there are many limitations are there. Like we have thousands and thousands of activities for a project. It is difficult for represent all the activities in a single chart. There's a main disadvantage of using bar chart. So what we do? We do milestone chart. As an improvement version of bar chart, we'll do milestone chart. Same version of x coordinate and y coordinate. X represents the time and y represents the activity. But y represents the milestone activities only. Okay. Next, after that, it's also being difficult. Milestones, sub-activities or interconnection between the activities, nothing is able to connect. So we are moving to the diagrams, network diagrams. That's how network diagrams are developed. These are nothing but the flow diagrams in which activities or events are connected logically and sequentially. The activities are connected logically and sequentially. The limitations of these two, 1 and 2, bar chart and milestone charts, are mostly managed in network diagram. And in network diagram, we have two type of diagram: activity on add, activity on arrow, and activity on node diagram. AOA as well as AON networks. So when we are speaking about network, definitely as final year students, you have noted these terms: CPM and PERT. What is CPM and PERT? CPM is critical path method and PERT is program evaluation and review technique. The last point is important. Both uses same calculations, almost similar. The main difference is that one is PERT is a probability based method, whereas CPM is for time estimate. I have the difference comparison. PERT is a probability based time estimate method, and CPM is more deterministic method. And in PERT we have time estimates as uncertainty, and we talk of range of duration, so 19 to 20 days of duration. And for CPM, it's specific. Historical data is available, so we have specific to 25 days, like that. In PERT, we have used for non-repetitive activities, like an activity which is newly introduced, like a research. It is a new thing, or a project which you are doing in a final year. It's a new thing, so you can apply PERT in that. But in CPM, it is used for repetitive activities, like construction of a residential building. When you are constructing a residential building in Kerala, or you are constructing a residential building in Tamil Nadu, or you are constructing a residential building in Dubai, it is a repeating activities. Activities involved in that is repetitive. So there you can use for CPM. And this concept of crashing is not deal with PERT, but it can be applied in CPM. That's it. Next is planning. Planning involves setting the objectives of a project and identifying various activities to be performed and determine the requirement of resources such as men, material, machinery, etc. The cost and time for all the activities are estimated, and a network diagram is developed showing sequence and the relationship, like predecessor or successor, between various activities during your planning stage. It is nothing but I am explaining you in a simple manner. You are going to bed at 11 p.m. and you are thinking about you have an assignment to be submitted at 12 p.m. or after the 4th lunch break. You have to submit an assignment. So you are planning. Tomorrow morning I will go to college at 9 a.m. and I will complete my assignment at 9:30 and I will submit in the first interval itself. Okay, so for that you need to if you have any doubt, I need to contact my friend X or Y, or I need to have my A4 sheets and sketch pens and my pencil and pen for drawing and all. If you have any calculation, you have to take your calculator. Like that you are planning for the next upcoming we are forecasting your activities and planning accordingly. That is nothing but is happening in our construction activities also. That is planning. What is scheduling? Scheduling is nothing but arranging these activities to finish it in on time. Why we are doing scheduling? To finish an activity in time. You have to submit your assignment before lunch break. So you have to complete it in at least in first interval. You have to complete it within the first interval. So what to complete in first interval? You get only 10 minutes break in your first interval. So I have to come 10 minutes before the class is started. The first hour is class is at 9:15. So I have to reach the class at 9. From 9 to 9:15, I can do my assignment, and after the first 2 hours, I have a break. I am planning to submit in the first break. So you achieved your goal. That is scheduling. Controlling is nothing but analyzing and evaluating the progress against the plan. That you can have another option. Or you are in bed at 11 p.m., right? So you can wake up and you can delay your sleep for 1 hour and complete the assignment today itself, and go to bed again and wake up with calm, relax in tomorrow and submit your assignment morning itself. That is controlling your activities. So planning, scheduling, controlling is the 3 things which we are managing in our construction management. Next is components of Port and Cpm. One thing which we have to know is the difference between activity and event. Otherwise, we will be getting confusing while drawing our networks. Activity is nothing but an action. It can represent an action or consumption of resources. In our activity, in our construction, it can be time, money, or energy. So, something which is consuming our resources, an action which consuming our resources are known as activity. And even or not is either the beginning or end of an activity representation. It is not going to consume any resources. It is usually represented in a circle shape as mentioned in the figure 8.2 and 8.1 represented. In I and J are the 2 events where A is an activity in the arrow. Okay, A is an activity in the arrow. So A will consume your resources, and I and J is a tail event and head event. You can see the arrow over here, right? So this head of the arrow end in an event called head event, and the tail of the arrow touches the tail event. And predecessor activity and successor activity I'm also mentioning. Sorry, I will mention you later. That's fine. Next is merge and burst activities. If so many activities are coming to a single node, it is known as merging activity, and so many is moving out of the activity or node, it is known as burst activities. Then the preceding activity and succeeding activity, look at the figure 8.4. Okay, in the figure 8.4, this represents a network. I, J, K, L are the nodes. A, B, C, D are the activities. So from the figure, it can clear that A and B are the first 2 activities that are starting simultaneously. And C can be started only after A is completed. Like your assignment. Writing your assignment is activity A. Submitting your assignment is activity C. You can submit your assignment only after you completed your assignment. Means writing your assignment. Only after completing your writings, then only you are able to submit your assignment. So C is submitting and A is writing. So C is the in this case, AB represents activity C and succeeding activity and preceding activity. The activity performed before the given event, that is known as preceding activity, and succeeding activity that is after the event. Okay. Then dummy activity. Dummy activities is nothing but which are not consuming any resources, but it represents the logical interrelation between activities in a network. So dummies are provided for what? Dummies are provided to show the logical interrelationships. Some of the major errors in a network which we are drawing is First one is figure 8.6. From a single node 1, two arrows are emerging. That first diagram is not correct. It can be represented like two different nodes and you can give an interconnection using a dummy. That is a correct version. Another error is a looping error. That means it is gone cyclic. It's again repeating. We don't have a starting, we don't have an ending event. It's looping error. And third one is that we need a starting event as well as an ending event. Then rule for construction a network is, I hope you all know that the length of the array has no significance. No single act. That means writing your assignment is a single activity. No need to represent 4 or 5 times. And similarly, the numbering of activity. If you are starting with 1, your last activity of submitting should be ending 5 or 6. Like that. The sequencing of number should be followed. And should be one. Try to avoid dummies in your network. And at least one start event. You need one start event and one end event in your network. Look at some of the common network shapes. So I'm giving you an example here. We have a network drawing example actually. So we have activities A to F. A to F, and these activities are connecting with the different nodes. A activity is connecting from 1 to 2, B from 2 to 3, C from 3 to 4, D from 3 to 5, E from 4 to 6, and F from 5 to 6. Description of the activity and predecessor and the duration of the time. Okay, so look at the figure 8.11. You have activity A, which is from 1 to 2. You have first drawn that 1 to 2. After 1 to 2, what? Now, for A activity, we have no predecessor. For B activity, it is from 2 to 3. So you have to put a new node 3 and the predecessor is A. So B activity can be started only after activity A is completed. Okay, activity B can be started only after A can be completed. Activity C and D, 3 to 4 and 3 to 5 respectively, both have predecessor B. So activity C and activity D, that is fixing the door or windows or wiring the house, both these activities can be started only after activity B is completed. Similarly, C is the predecessor of E and D is the predecessor of F. So that comes to a network. I hope it is clear. That is how you are able to draw a network. Next is critical path analysis. Critical path analysis, like nothing but we have different, like if you see in this previous diagram, we have the path 1, 2, 3, 4 and 6 and 1, 2, 3, 5, 6. You have 2 paths to come to 6. You have 2 paths to come to your 6. From 1 to 6, you have 1, 2, 3, 4, 6, 1, 2, 3, 5, 6. You have 2 paths. Which path will take more time? That represents the critical path. The critical path of any network is the longest path through which the entire network is the longest path. Critical path is the longest path, and the activities in the critical path are known as critical activities. Okay, so I'm moving to the so these critical and the activities which are not belong to the critical path are non-critical activity. So the slack time means there can be a delay. If that activities can be delayed so that it will not affect the duration, final duration of the project. That time is known as slack time. For non-critical activity, you have slack time. But for critical activity, we have no slack. Your slack will be 0. Next, calculation and all, I will show you in an example. I will show you this in an example. Next is your float. Float is similar to that of slack. It is the float is the difference between the latest start time of an activity and the earliest start of an activity. Latest start and earliest start. Difference between earliest start or latest start or a latest finish to earliest finish. That is the total float. Then what is free float? Free float is nothing but the time taken by which the completion of an activity can be delayed from its early finish time without affecting the early start of the succeeding activity. Like I have said, we have to wake up in the morning and get ready for the college, and we have the breakfast, and we have to go to college at 9 a.m. and write your assignments, and you have to submit it. This is your activities. Okay, you can delay your food, taking your food. You can delay your food, but it should not affect your assignment writing process or assignment writing activity. That available fluctuation is known as free float. So what is independent float? The amount of time by which an activity can be delayed without affecting the early start of immediate activity followed by the activities, but should not affect. In this series of activity, you can delay any of the activities. But whatever your activities you delayed or you late start or whatever happens, you have to submit your assignment before lunch break. That kind of float is known as independent float. Free float is nothing but total float minus head event of the slack, and independent float is nothing but free float minus tail event of the slack. The negative value of independent float is considered to be 0. That is an important value or important question that you can expect is the negative value of independent float is considered to be 0. So here you have a problem of critical path. I am giving you a problem. From management side, you can expect problems of 2 marks problems you can expect. A project schedule has the following characteristics are shown in the table. So you are giving the activities, activity name, duration. Okay. You are asked to construct a network and calculate the T and TL, TM and earliest time and latest time of each activity and find the critical path. This is your task. Okay. So I am showing you, we have this table and network diagram. We are drawing network diagram. So we have 1 to 2. From node 1 to node 2, you have activity A, and from node 1 to node 3, you have activity B. Okay, activity B. And from 2 to 4, you have activity C, and like that we are making out drawing. We have drawn out network. Okay, and we are mentioning our duration in times, in days. Okay, so how to, this is a calculation. You just not need to see this. I will show you how to calculate this. So we have the duration over here. All the activities and duration. So I am starting with 0. I am starting with 0. So what is the duration from 1 to 2? It is 4. So 0 plus 4, this will come to 4. This 1 to 3, it is 0 to 0 plus 1, it is 1. From 2 to 4, what is this duration? It will take 4 days plus 1 day. That is, it will take 5 days. Okay, from 3 to 4, 1 plus 2. This 2 again come to this node. So we are striking this 2. Why? We have to take the largest number for earliest. So for our TE calculation, earliest time calculation. So we are taking 5. So from 4 to 9, we have an activity with 5 duration. 5 plus 5 will give you 10. From 3 to 5, you have 6 duration. So 1 plus 6, we will give you 7. Okay. From 5 to 7, you have 8 days. So that will make it as 15 days. Okay. From 5 to 5 to 6, it will take 7 plus 4. 11 days. Here 15 plus 2 you will take 17 days. Here you will take 11 plus 1 12 days. So you are striking this 12 here. So we have to take this highest value. So I am striking this 12 and taking 17. 17 plus 5 you will take 22 days to complete your work, and 10 plus 7 you will take 17 days. So you have to take your highest value. So I am striking this one. This 22 will be your TE. For calculation of TL, the reverse process of what we have done now. This 22 minus 5 is 17. 17 minus 1, 16. 16 minus 4, 12. Hold there. 17 minus 2, it's 15. 15 minus 8, here we get another number 7. In case of TL calculation, we have to take the lowest value. So I am taking 7 here. 7 minus 6, I am getting 1. 1 minus 1, I am getting 0 here. We have another more path. 22 minus 7, that is 22 minus 7. Sorry, 22 minus 7, that is, we will get 15. 15 minus 5, we will get 10 here. 10 minus 1, you will get 9 over same here. So you have 9 and 1, you will strike the highest number here for TL calculation. So that's it. So we have calculated out TE as well as TL. TE minus TL will give you a float value. Okay, TE minus TL will give you a float value. That is 0 minus 0, float is 0. 1 minus 1, your float is 0. Here you have mentioned one thing. I forgot to add an activity. Here we have 10. 10 minus 1, this is 9. Okay. 9 minus 4, you have 5. 10 minus 5, you have 5. 7 minus 7, you have 0. 15 minus 15, you have 0. 15 minus 10, you have 5. 11 minus 6, you have 5. 17 minus 17, 0. 22, 0. So the activity with 0 float are known as critical activity. So I am connecting activity with 0 float. So you are connecting this one, this one, this one, this one, this one. So our critical activity path is 1, 3, 5, 7, 8, 10. And these activities are critical. Okay. I hope you are clear. And this will show the calculation and all. Just forget about all these things. This is what we have done. Okay. We have done that problem. So this part will be of critical. 1, 3, 5, 7, 8, 10. The similar one which we are getting in our next previous window. Moving to our PERT problem. I have mentioned you PERT is based on probability based. So that is T0, TM, TP. These are the most 3 important probability based time estimates for your PERT analysis. Sorry, for your PERT analysis. Optimistic time is nothing but most favorable situations to occur an activity. That is optimistic time. Like you can write your assignment. One of your tasks is to write your assignment. Okay. You can write your assignment within 10 minutes if all the situations are favorable to you. Okay. If you have a friend to ask, it's a favorable situation. Like if all the situations are favorable, you can complete your assignment in 10 minutes. Or in natural circumstances, like if your friend is late, you may complete your assignment in 15 minutes. Okay. That is most likely time. Normal situation, how much time you will require to complete your activity. Pessimistic time is the most worst situation. You came to college at 9 a.m. but you heard that you have a special class at 9 a.m. So you have no time to write the assignment. So you will take nearly half an hour to complete your assignment without knowing your teacher. you will definitely do that. You have to complete and submit the assignment. So you will write in your special class time. So these are the 3 time estimates. Optimistic means the most favorable situations for the occurrence. Most likely is the normal situation. Pessimistic means the worst situation in which you are completing your activity. So these are the 3 time estimates. So we are giving the 3 time estimates and we have to calculate the total duration of each activity in PERT. So equation is T0 plus 4Tm plus Tp divided by 6, and we have to calculate the variance and probability. So variance is Tp minus T0 divided by 6 the whole square, and probability is Ts minus T, means expected time minus, this scheduled time minus expected time divided by square root of variance of sum of variance in critical path. We will moving directly to these equations are most important, and definitely you can expect 2 questions from using this network and these equations. Moving to the example directly, as the time is 3:30, I am rushing to finish. Just moving directly to a problem. So we have J activities, A to J activities, and we have the T0, Tm and Tp time. We have to draw the critical network diagram, critical path, and we have another question. If the project is completing in 19 days, what is its probability? If the probability is less than 20%, what is its completing in 22 days? So these are the 3 questions which we are asking. Okay. So we have the network, you have the predecessor, you have the activities and nodes. Using that, you are drawing the network. Even if we are not able to draw the network, this can be directly substituted in the equation and you can get the value. You have the equation of TE. T0 you have given, Tm you have given, Tp you have given. You can calculate Ta with this equation. We can calculate Ta with this equation and you can calculate variance using Tp minus T0 divided by 6 whole square. From that, you have to draw the network and identify. Using this Ta, you have to draw the network and identify the critical activities. So the highlighted activities are the critical activities. 1, 4, 6, 7 is the critical activity for this particular diagram. We are constructing the network and finding the TE and TL and finding the slack and finding the critical activity. So our A part and B part is done. Moving to our C part, probability part. First question is we have as a probability of completing in 19 days. So in this question we are getting 22 days. We are taking 22 days to complete our projects. Okay, we are taking 22 days to complete our project. Here we are asking what is the probability of completing the project in 90 days. Okay, what is the it is actually done in 22 days. If it is possible, what is the probability to complete in 19 days? Nothing but you have the equation, substitute it directly. Ts is the scheduled time, 19 days. Te is the expected, which what we are getting from the network, divided by square root of variance of all the critical activities. So critical activities are, I have already mentioned, 1, 4, 6. So the variance of sigma square of sum of sigma square of all the activities will give you the probability. We are getting minus 1.3416. Okay, so we are always 50-50 probability. So we have the normal chart, logbook. We have the normal chart. From that we are getting the Z value for Z value corresponding to 1.3416. Yeah, you might have used this normal tables in your maths classes. That small 5 to 6 page book with the blue color. From the corresponding Z value, you are getting for value as 4.4099. So you will get the probability as 9.01%. So that 22 days is taken to complete the project, and if you are planning to complete in 19 days, it will take 9.01%. So we have another question. If the probability is less than 20%, what is the probability in 24 days? Similar way, we are calculating the same and we are getting 81.33%. So definitely you can expect a 2-mark question from this area. Another important part of construction management is cost analysis. Like we have 5 JCBs in our site. So what will it cost? How long? Using 5 JCB, we can complete 3 days excavation. If I am providing 6 JCB, how long it will take to complete? And if I am taking 2 JCB from yours, how long it will take to complete? These analysis can be done. That all comes under cost analysis. So we have 4 terms in cost analysis. First is normal time. In normal condition, you have 4 JCBs in your site. You have 4 JCB. That is a normal condition. So in that normal condition, what is the time taken and what is the cost corresponding? That is the normal cost as well as normal time. Okay. Crashing time is not crashing time and crashing cost is nothing. I am giving you 8 JCB and you have to finish in 1 day. That time or that cost is known as crash cost or crash time. Okay, so the ratio of these is known as cost law. It is nothing but equation is given, direct equation is there. Crash cost minus normal cost divided by normal time minus crash time. That is cost law. I am getting into the problem directly. So first you have to you are given a problem. This is the network, this is the activities, and this is the time duration. Normal condition, this is the time and cost. When crashing, this is the time and cost. So you have to and indirect cost you are paying is 20 per day. We have 2 type of cost, direct cost as well as indirect cost. Direct cost is the cost of equipment and that all things. But indirect cost is something which is not directly related to a concession, but it is indirectly related. Like we have a concession site, congested concession site, and we are taking our nearby site for our loading activities, and we are paying rent per day. Okay, and if actual duration is 22 days and we are completing in 19 days, so 2 days rent is less. So direct cost is always increasing while crashing, and indirect cost like this kind of cost is reducing when it goes to crashing. So the solution is first we have to draw the network. We have given the activity and normal time. So from the activity and normal time, we have to draw the network and find the critical path. After finding the critical path, we have to find the cost slope. Cost slope we have already mentioned the equation. Crash cost minus normal cost divided by normal time minus crash time. So we have to calculate the cost slope column. From the cost slope column, we have to rank that. Rank means minimum cost slope we put it as 1. Then likewise we proceed. If in this table we can see that the minimum cost slope is 10. So I am ranking it as 1. Next is 15, ranking it is 2. Next is 20, ranking it is to 3, 4, 5, like that. After ranking, I have 3 paths in this network. What are they? 1 to 5. That is one. Path 1, our critical path. Another path is 1 to 4 and 5. That is another path. Another path is 1, 3, 4, 5. These are the 3 paths. And we are providing the crashing time also in each of the activities. So we are crashing each time and we are finding this network. We are finding this network. We are crashing until all the paths will become critical. And then the normal cost will give you the sum of the total crashed amount. So moving to, so first in our starting we have completing in 14 days with our critical path is 1 to 4 without direct cost and indirect cost. So direct cost plus indirect cost will give you the total cost. When we are moving to 10 days duration, so that means we are crashing 1 to 2, 2 to 5 and 2 to 4 and 2 to 4 crashing, we are getting 3 critical paths. For a single network, we are getting 3 critical paths. So we are calculating the cost and indirect cost, total cost. From the table, what is your inference is that nothing but if the project duration is decreasing, your direct cost is increasing. Okay, your direct cost is increasing, but your indirect cost is decreasing. Since your direct cost has more significant effect on the total cost, it is also increasing. Okay, and one more thing, it is not possible to crash more than 10 days as all the activities are in critical path. All the activities are in critical path if you are crashing up to 10 days. Hence, the minimum project duration that is 10 days with an expenditure of 970 rupees. This is your interpretation from this crashing. Okay, I am sharing this PPT and I am adding some of the 4 to 5 problems for you to work out. If you have any work issues or if you are facing any difficulty in working out this network diagrams, definitely you can contact me. I will share. This is 1, 2, 3, 4, 5, 6. I'm adding 6 questions, extra questions for you people to solve out. Okay, that's it. Thank you. Thank you all. So, if you have any doubt, you can ask
Can you
me.
share this PPT?
Yeah, sure. I will share. I will share you. Actually, I want you people to work on your last 6 extra questions that I given. Then only you are able to draw the network diagram. You can definitely expect a problem from the management section with 2 to 4 mark can be expected. Please practice that last 6 questions. If you have any doubt from our slide of management, please ask me right now. So all clear. I hope it is clear for you. Thank you then. If you have no more questions to discuss. Hello? Hello?
Yes, ma'am. Yes, ma'am. Clear, ma'am. Thank you so much for the class.
Okay, thank you. Thank you so much. I hope a faculty is there with you. Okay, you can contact me through mail. I will share my mail ID. Just a minute. You can note my mail ID and you can contact me through mail. This is my mail ID. If you have any doubt and all, you can contact me.
Ma'am, can you paste your mail ID in chat box?
Yeah, sure. This is my mail ID. You can contact me if you have any further doubts or clarification required. I I will share this PPT as well as a written note for this particular syllabus. Please go through that. It may be much more detailed of more than what I have explained. Just go through that. And I am requesting everyone to do at least 4 to 5 network so that you can save more time when you are solving your gate problems, or else you are solving like for the first time it will take more time to solve. You have to practice drawing network. At least I am adding 6 questions in at the end of my slide. Please practice that slides. So I hope I am done with this from my side. If you have anything, I will wait for a few minutes.
Excuse me, ma'am.
Hello, ma'am.
Yeah.
Yes, ma'am. Yes, ma'am. We're busy with some official work, ma'am.
Yeah, sure, sir.
Yes, ma'am. Participants, students, you have any related queries? Any queries? No. Okay.
Actually, they have asked, sir. We have we have completed 5 minutes before.
Yes,
Like
ma'am.
3:40 we have completed. We have a small discussion of
Sure, ma'am. Sure, ma'am.
regarding the same.
Okay, ma'am. Okay, ma'am. No issue, ma'am. Okay, ma'am. Ma'am, I need your PPT, ma'am, for reference.
Yes, sir. Yes, sir. Please send me. I will send my PPT to the mail ID. This mail ID, sir.
Yes, ma'am. This mail ID, ma'am. Yes, yes, ma'am.
To one which you have shared me the link, right?
Ma'am, you need to share Google, sir, ma'am. I will collect from that.
Yeah, fine, fine. Yeah, fine. I will give to Google.
Yeah, yes, ma'am. Yes. Okay, ma'am. Okay. Thank you, ma'am. Thanks for your presence, ma'am. Yeah.
Thank you. Thank you so much for giving me an opportunity like this. After
Yes,
a long time, like after nearly 2 years, I am taking class for